All right, so this is my project, rotated human detection on fisheye cameras. So what is the purpose of this project? The purpose is I want to make a traffic detection software. This project is a subset of that software. So basically, I think that security cameras could offer more than just security. I think there's a lot of data that can be collected in security cameras. And I think that a software that makes it easy and simple to detect this data or to collect this data could be useful. I think that this data collection software could allow small businesses to increase productivity, drive their sales up, influence buying decisions, and much more. I think that, for example, if you have a grocery store, it could be useful to know which aisles your customers are visiting most. You could target different products in those aisles, or you could just make sure those aisles are restocked more often to drive your sales up. And then there's one main problem or project that I wanted to tackle in this project, and that is overhead fisheye security cameras. They're a challenging subset of images that you would have to work with in this software. The challenges are that the objects in them are often skewed, disproportional, or oddly angled. This can make it hard for an object decision to detect these objects, or it could also make it so the bounding boxes of axis aligned bounding boxes are very big. That's where rotated bounding boxes come into play. I think this could improve accuracy of the data collection, which is important. So basically, my approach is I decided to build off MP3. So I used the CDOF dataset, which was a dataset created by people at Boston University. It has 1,200 frames, and it has a max number of people of 11 per frame. And then it offers rotated bounding boxes as ground truth. So I extended RetInternet to be able to handle the rotated bounding boxes. So I first changed it to a binary classification. It's either zero background or one person. I then also added a rotation to the anchors. So I added a fifth dimension that has an angle dimension that rotates the bounding boxes. And then I implemented smooth L1 loss because it was less sensitive to outliers for rotated bounding box. And then I implemented binary cross entropy loss for the binary classification. Um, so there was one main challenge in this project that I faced, and that was the IOU calculation. The IOU calculation is very computationally expensive for rotated bounding boxes. As you can look at the bottom left over there, there is axis aligned is just width times height. It's very easy to get the intersection. It can be or vectorized. And then there's rotated bounding boxes, which is just some arbitrary shape, which can be a lot harder to get the intersection. It's much harder to vectorize, and so this actually added a lot of training time, and this was one of the biggest bottlenecks in my project. All right, so for only being able to train the model for 10K iterations, this took about 10 hours to train. The results are actually pretty good. So as you can see, the losses are both on decreasing trends, so they should continue to decrease. This means I expect the model to continue to improve as the more iterations as it trains. And then also the AP is at 0.15 at 10K iterations. And you can see on the graph in the top right that it's continuously going up. Um, and so the detections at 10K iterations are actually fairly good. If you look at the bottom right, this is at 10K iterations. The green boxes are the 10K iterations results, and then the red boxes are the ground truth. So you can see that the green boxes don't directly match with the ground truth, but there is a green box on every person in the frame, and there's a lot of people in this frame. So I would consider this pretty good at the point it's at. And then on the left side is actually green is 5K iterations and blue is 10K iterations. So this is a comparison between the two. And you can see that green only predicts 3 of the people in the scene at 5K iterations, but blue actually predicts more people in the scene. So I found that as the iterations increase, the ability to be able to predict more people in the frame at a time got better. This was a trend over multiple photos. So overall, the results were pretty good for only 10K iterations. There's a few key takeaways that I got from this project. Uh, One of them is shapes should be consistent throughout a model pipeline. I made the mistake of making the ground truth and the anchors different shapes when they're read in. I had to do a lot of conversions throughout the pipeline, and I also had a lot of errors. So this is one of the biggest things is I should keep the shapes consistent throughout the model pipelines. I also learned that rotating bounding boxes are way more computationally expensive than axis aligned bounding boxes. I wasn't expecting this. I was expecting it to be closer training times to axis align, but it wasn't. And then also a 3080 is not enough power for an oriented bounding box detection model.